Hey there, and welcome to my channel. In this tutorial we will talk about equivalent static method or linear static method, okay, using ETABS software. Okay, so I will design or model a building. Okay, so after that I will follow all the stepping procedures step by step, and we will complete its analysis process. Okay, so let's start. I will select new model. Okay, after that I will use built-in setting width. Okay, display unit will be metric standard international. Okay, so and still section database will be this one. Okay, and still design code will be American standard. Okay, the latest version, and concrete design code will be American Concrete Institute 318. Okay, so now in this template, okay, I will select number of stories will be 5, okay, and in x and y directions the same. Okay, so and also spacing will be 6 meter and also 6 meter. Okay, and the number of stories will be 6. Okay, and the typical story height will be 3.3 and 3.3. okay, 3.3. okay, and after that I will press good only, and okay. Yes, the model has been created. This is a window plan view and 3D view, okay, and explorer. Okay, so now I will go to define material. Okay, to define the material. Okay, so I will modify this one 4000 psi. Okay, so because I will use American Society of Civil Engineering and the American Concrete Institute, okay, which is also known as the American standards. Okay, so I will do not change other properties. Okay, so after that I will press OK, and now this time I will add new properties. Okay, United States, okay, concrete, and customary, this time 3000 psi. Okay, so after that I will press OK. So I have defined, okay, concrete material. Okay, and I will use this 60, okay, for rebar. Okay, rebar materials. Okay, so after that, okay, so I will use this rebar materials. Okay, and others are predefined. Okay, but I'm not going to use them. Okay, after that I will press OK. Now I'm going to define the section properties, frame sections. Okay, I will delete some properties, okay, here, which I do not want to use them. Okay, so I will define the concrete rectangular concrete. Okay, so I will define here beam. Okay, material will be 4000 psi, and also it will be concrete rectangular. Okay, and it will be 450 mm and 430 mm. Okay, so shore reverse will be beam. Okay, and I will use this one 60, which I have specified there and defined. Okay, and top cover will be 440 and also 40, and also okay, modifiers I will show moment of inertia will be 0.7, okay, 35 for beams and 0.35. okay, after that okay, and okay, I will delete this one. Now I will add new property. Okay, so column, okay, okay, and material will be 4000 psi, okay, and it will be 500 and 500, okay. Reverse will be columns, okay, the same reverse material which I have used for beams, okay, and 40 mm clear cover, okay, and other reinforcement details will be determined by a software, okay. After that, okay, and modifiers will change. This one, moment of inertia about axis 2 will be 0.7 and also 0.7, okay, and okay. So I have defined beams and columns. After that, I'll press OK. Now I will define slab sections, okay. I will go here, add new property, okay, slab, and material will be 3000 psi, okay, and the thickness will be 150, okay, slab, and okay. So modify it, the modeling type will be sharpen, okay. So I will delete this one as extra, and also this one, okay. So now I have defined column sections, beam sections, slab sections, okay. Now I will go here to draw the structure, okay. So I will come here for this one, quick draw, and I will select property type will be columns, okay, and after that I will go here to select all stories, and I will press here, look here, I will just pick a point or draw in single story, but it will be drawn for other stories as well, okay. So look here, the column is going to be drawn, okay, and here, also here, and here, okay. If you want to just quickly draw it, just click here and drag your cursor, it will be drawn, okay. So now I will go here again, and this time I will select here beam, okay. So I will select all stories, okay. So click here, and here. Look here, I'm just working in a single story, but the process of modeling and drawing is going on for other stories, the same as for a single story, okay, and here as well. Okay, otherwise just click here and drag, it will be drawn, okay. The beams and columns has been completed, okay. Now I've been going for slab, okay. I will just go, you can just choose here this option, okay, and come here and select slab. After that, just select this point, okay, grid point, and another grid point, this grid point, okay, and this grid point, and back to the initial point, okay. So the slabs has been drawn, okay. So, and you can choose this draw rectangular floor wall section, which is comparatively quicker than previous options, okay. I will just select this grid point and will drag, okay, to another grid point, okay. Select this grid point and drag, select this point and just drag, okay. Select this point and just drag, okay. And more quicker options will be this one, draw quick draw wall, okay. Select slab and just press by one click, you will draw all the slabs, okay. Easy, very easy, okay. Now I will go to base, okay. I will select a single story and will delete these slabs, okay, which I do not need in base, okay. You will just press this one, delete, okay, and I will select these nodes, okay. I will go here and joints, restraints, I will fix it, okay. So now I will go here to define the mass source. Okay, I will define add new mass source. Okay, mass source. Okay, specified load pattern. Okay, and also here the dead load multipliers will be 1, and also live load 25%. Okay, add. Okay, and also press OK. Come here, mass source, and select this extra one. Okay, after that press OK. Okay, now come here and to the load pattern. Okay, I will define earthquake. Okay, X directions. Okay, I will select seismic code. Okay, seismic, and the code will be American Society of Civil Engineering 716. Okay, after that I will add new load case, the same as for X negative. Okay, add new load case, and also for Y, and the seismic type and American Society of Civil Engineering 716 latest version code, and also for Y negative the same code. Okay, so also for wind X. Okay, the same code, but the type will be wind. Okay, so the same code also for Y direction. Okay, the same code. After that I will modify this one. I will just select X directions plus eccentricity. Okay, so and I will change here. The SS values will be 1.15 and this one will be 0.51. Okay, these values will be chosen according to your structure locations. Okay, so and the long period will be H, the site class will be B. Okay, in the time period will be program determined. Okay, and the response modification factor will be 7 and aberration factor is 3. Okay, and this CD will be 5.5 and occupancy importance factor will be 1.2. Okay, after that I'll press OK. Same as for X negative directions. Okay, X directions minus eccentricity. Okay, after that 1.15. Okay, 0.51. Okay, the site class is B. Okay, and the response modification factor or R factor is 7. Okay, and system aberration factor is 3, and also others are the same. Okay, but I is 1.2. Okay, and time period will be program determined. Okay, after that I will go for Y axis earthquake and Y directions. I will press Y directions plus eccentricity. Okay, and SS will be 1.15. Okay, and 0.51. Okay, and the class side class will be B. Okay, and modification R factor will be 7, 3, the same, and 1.2. Okay, and program calculated. Okay, the ranges for all stories. Okay, and also same as for Y earthquake Y negative directions. Okay, I will come here 1.15. Okay, 0.51. Okay, and the site class is B. Okay, and 7, 3, same, and 1.2. After that I will press OK, and come is for wind X directions modified. Okay, exposure from extents of diaphragm will be 100. Okay, and B exposure type, and also the range will be from historic first. Okay, and wind pressure coefficient will be program determined, and press OK. Also same as for wind Y, exposure extent will be 100. Wind speed. Okay, the exposure type is B. Okay, and also ranges from 4th story up to 6th. After that press OK. Okay, now I will go here, so I will add load combinations. Okay, I will come here at default design combo concrete frame. Okay, and also afterward I will just convert to nonlinear decompose or just press OK. This one. Okay, now I will come here, will define the response spectrum. Okay, I will select American Society of Civil Engineering 716. Okay, add new function. Okay, response spectrum. Okay, method. Okay, so it is SS value will be 1.15 and this one will be 0.51. Okay, and each the site class is B. Okay, and also the damping ratio will be 5%. Okay, after that, okay, look here, the points for period and the points for accelerations. Okay, I will just select or click convert to user defined. Okay, look here, the defined functions for periods and values for accelerations. Okay, and this is the graph. Okay, the response spectrum curve. Okay, if you want to check it is values as coordinates, you will look here to its cursor point and we'll see its coordinates. After that I'll press OK. Okay, and OK. Now I'm going to define and load cases. Okay, and look here as a linear static. Okay, load cases are predefined for earthquake X directions, earthquake Y directions. Okay, and wind load and others. Okay, dead load, live load. Okay, I'm not going to change or modify this one. Okay, it is okay because I want to give us equivalent static method or linear static method. Okay, I will just add new case. Okay, response spectrum. Okay, method in X directions. Okay, because I want match response spectrum case to the linear static method. Okay, afterward I will just now select here response spectrum. Okay, and I will add here, so I will choose acceleration here and load name will be U1 and also function will be response spectrum, and here this value will be 1. Okay, and it may change later on in case of matching response spectrum with static linear method. Okay, so in that case the scale factor may be changed, but this time I will just add as a 1. Okay, and after that the model load case will be model and more model combination method will be CQC. Okay, so and also the directional combination type will be square root of sum of squares. Okay, or SRSS. Okay, and model damping will be 5%. Okay, so and also the diaphragm eccentricity, which as we are using rigid diaphragm. Okay, I will modify this one and I will use as a 5%. Okay, after that OK and press OK. So now I will take a copy of this one, or copy of case. Okay, so I will just change here for Y and I will select here U2. Okay, others are the same. Okay, CQC. Okay, and SRSS. Okay, 5% diaphragm eccentricity and also model damping is also 5%. Okay, and press OK. After that all the load cases are defined correctly. Okay, so for linear static case, and after that I'll press OK. Okay, so now I will select here, I will come here and select here, or otherwise I will go here and will select all trays. Okay, I will select all the slabs. Okay, so after that I will come here, assign shell load here, shell load uniform. Okay, So I will apply dead and live load. Okay, so I will select here load pattern name as a dead, and I will select its values as 1.44 kilonewton by meter square. Okay, and press apply. Okay, so I haven't selected this one. Apply. Okay, so and okay, now I will select all the slabs again. Okay, so I will go here, assign shell load uniform. Okay, this time live load and 1.53 kilonewton by meter square. Okay, so it will be gravity and apply. Okay, and okay, so let's confirm it. Select and load. Yes, the dead and live load has been applied. Okay, so now I will select here object type and also floors. Select all floors has been selected. After that I will go here to assign. Okay, and shell and diaphragm here D1 apply. Okay, the diaphragm has been applied. Okay, so now I will just check once again here the load case. So come here and check the load case. Yes, we want to apply the linear static method. Okay, or linear static analysis. Okay, or equivalent static analysis. Okay, so this one I do not know why it has been defined. I have deleted. Okay, because we want linear analysis. Okay, and I have defined response spectrum for both direction as well. Okay, and after that I may match this linear static and response spectrum also if there was like the result was not correct. Okay, so after that I will press OK. So now we have done all the procedures. Now I will just come here, analysis. I will check model, whether the model is correct or not. I will select all. Okay, so it is checking. Okay, and creating model, so whether it is model is correct or not. Okay, yeah, it is showing model has been checked, no warning message was generated. Okay, so it is stating that we have designed our model correctly. Okay, so now I will go here for set load cases. Okay, I want to run all the loads case. Okay, so I will just go for run now. Okay, before that I have to save it. Okay, I will give a name, linear static analysis. So the model receiving and creating analysis model. Okay, so analysis process is going to start. It will take a while and we'll see its results. The analysis has been completed. Okay, look here. Now I'm going here for display and show table. I will come here and will select this option. Okay, structure output. Okay, after that I'll press OK. Okay, we are coming here. So this is the base shear for x directions and this is the base shear for y direction. Okay, so both are the same. Okay, and we are coming here. So coming here to the response spectrum in x directions, okay, and also in y directions, okay, they are the same. So but still, if you want to match the results for linear static and response spectrum, okay, what you will do, you will come here to the earthquake, okay, you will take these values, okay, like 1136.95, okay, so but you want to match the linear static, okay, and response spectrum analysis results, okay, you will take this earthquake or base shear, okay, which is 11, okay, 36.9521, okay, divide by, okay, we are coming here to the response spectrum, okay, like this one, okay, it is 0.5229 divided by, okay, 0.5229, okay, so it's giving 2017, like this value, okay, I will just copy this one, okay, and we'll go here and we'll go, I will done it this one, okay, I will go here define, okay, so load pattern, okay, I will go here define, also both case, okay, come here, response spectrum, modify, and scale factor, okay, paste it here, okay, after that, okay, and same as for y, okay, modify, okay, and paste it here, okay, and okay, and in this way you are going to scale a factor, okay. So if your results were not correct, okay, and you want to match the linear static and response spectrum, okay, you will follow this way, okay. So if its result is okay, then no need to change the scale factor, okay. Now I'm going come here and story response plot, okay, I will click here and select maximum story displacement, okay, earthquake x directions for the combinations, okay, it is the maximum story displacement, okay, earthquake x directions and also earthquake y direction, okay, this is the maximum story displacement, it is about 32.83, okay, so and about x-axis it is also the same 32.83, okay, so and coming here to the maximum story drift, okay, it is the maximum story drift is like in story 2, okay, and story 2, yes, and for earthquake y direction, okay, this is the maximum story drifts for y directions, okay, so and story shear for earthquake y direction, okay, look here, and also for earthquake x as well, it is story shear, okay, So our turning moment, okay, for earthquake X, earthquake Y, okay. So like look here, when I come into the storage here, so if you want to see its result, its report, summary report, you will just press this one, okay. So it is a summary report about about storage here. So all the information is given here. So if you want to detailed report as well, okay, look here. Its information is showing here, okay. So if you want to just export to Word file or document, you will just press this one, okay. So, and if you wanna just transfer or convert this show table and come here and format it, it will be exported to Excel sheet, okay. So now I'm coming here to the deform shape, okay, and select the load case dead load, okay, and press OK. Look here, so it is moment M33, okay. Moment M33, and also look here for share 22, okay. And if you want to just go for load combinations, you will just change to the combo, okay. So also to the axial force and torsionals, other information is given here, okay. So if you want to just go for the concrete frame check, you will just come here and will press for start design check, okay. The check will be going on and will complete, okay. So like look here, I will select concrete design check, okay. It has been started and it is checking each and every member one by one. Okay, the design check has been completed, okay. If you want to check its details, you will just click here and will select for details, okay. Look here, ETABS concrete frame, okay, for columns, okay. Rebar percentage and others informations, okay, has been shown here, okay. So it was all about the linear static analysis for equivalent static method, okay. Thank you so much for your attention. Have a great time.